Hi everyone, welcome again to TrueML episode. And I'm Nikunj, co-founder and CEO at True Foundry. And today we have with us Lewis, who is a senior director of machine learning at Senn AI, who has kindly agreed to join us and share his experiences working, studying, and building in machine learning. Lewis, welcome to the episode of TrueML. And I would invite you to share a little bit more about your background, how you got where you are today, maybe through your PhD days, how you got into machine learning. Would love to hear a bit about your background.
Absolutely. First of all, thank you so much for the invitation to be here today, sharing some insights about my career in machine learning, and hoping inspiring others to also start this career and pursuing the higher goals on it with that foster adoption of AI. As you know, that's never enough. About me, so I started my career as a software engineer. Okay, so background software engineer, comprehensive degree, went to industry, and by accident on industry, so I started working with data reporting tools. Okay, so back in the day that Looker and all these modern stack didn't existed. Okay, so all of these imply so hardcore development. That was 2 years on a consultancy firm, and then I received a phone call from the person that had supervised my master's degree with a challenge to work on some sort of predictive analytics. Okay,
Okay.
so which sounded to me a bit sci-fi, but I wanted a hard challenge. I'm a person of hard challenges. So I wanted a hard challenge that sounded I agreed to meet. Okay, so and then through a sequence of meetings, I was convinced to pursue a PhD degree. Okay, to move back to academia, join a Blue Sky research lab, so and pursue a PhD on machine learning. This PhD was an industry-funded PhD. Okay, from two stakeholders from transportation industry, um, on a time that all of these things, data science, data mining, machine learning, were still on early days, particularly in Europe and then in Portugal, which is my home
Yeah.
country, even more. And I had no idea what I was getting into. So I had, during my master's degree, so I had some training on what they call AI back in the time. That was things from more for computer native software engineering and more old conceptions and challenges on reasoning, so Prolog and other things. So on the broader AI spectrum, but the machine learning was something that I knew very little about when I started that degree, and when I joined this Blue Sky Research Lab. So most of the people there were either mathematicians or statisticians, or like I like to call professional mathematicians. Okay, so I really needed to polish my maths, my algebra, and my stats to actually understand what they were doing. Okay, it was the first barrier. Okay, it was looking around, say, oh, beautiful math on a whiteboard, why does this matter, what you are trying to solve here. Okay, so that was like the first barrier was that, and that after I start being able to understand, the second barrier is, oh, how can I add up to what is the state of art and what is the challenge on this topic. And then when I started actually understanding that, the first thing, I never stopped being an engineer. Okay, and I never stopped at my module. What was during my PhD that I realized what makes me step up in the morning and go, it makes an impact on the world around you. Okay, really transform the world around you with technology, and in this case with machine learning, which I saw like to be the next border, the next let's say border of digital revolution was machine learning, with the access of large amounts of data that were being generated at the time, and that still today keep being generated at a crazy scale. Um, and with that, I start thinking, okay, we are developing these algorithms that back then in the lab were basically being proven right on a board or being tested on a toy data set or some data sets that were real world, but naturally well will be polished and very prepared
Yeah.
for the machine learning tasks, which has nothing to do with the real world data set, as we well know. And start thinking, hey, wait a second, how we actually do this to make money? Okay, to the engineering mindset, to make a service that works at scale, it's robust. And it was incredibly hard back in 2010, 2011. So we're talking about on-prem systems. So cloud existed, but was
Right.
minority. So we are talking, most of the things were R. We're talking about R. Okay, not talking about Python. Python was
Right.
coming still on the train, and we're talking about, even the word MLOps was something that didn't exist. Right?
That's great. Yeah.
So you had to think hardcore engineering concepts. Okay, and now to apply concepts even from software delivery lifecycle to something that is different. Okay,
Right.
so I like to say I was doing machine learning during the day, and I was doing MLOps at night. Okay,
Wow.
because try to have an impact. And that's it. It's how I jumped on the world of machine learning, where I've been for the last 15 years, both on the modeling side, but also on all the infrastructure around machine learning to make sure that we can operate those models and services on a profitable way, on a way that affects real world and that brings growth to our economy and benefits a greater good. Okay, depending on the application, obviously. And the last 8 years managing teams first, and later department, and occupying positions at executive leadership level, managing multiple teams and large budgets on the space of data, machine learning, and AI.
It's fascinating, Lewis. I think you have had this very, very diverse career where you started from engineering, got into more machine learning, maths, stats, worked with, I guess, professionals in the field, and now you've got into leadership positions, where you are, of course, you have managed teams of dozens of engineers altogether. It's amazing. um, fast forward to today, when you are a senior director, tell us a little bit more about your current role here. What's the type of problems that you're trying to solve with machine learning, and how have you structured your team to solve these problems, basically, right? So a view into the problems and a view into the team would be very helpful.
Yeah, absolutely. So first, look into the problems and look to the problems. And look to Sennder, which is a company that I see today. And Sennder is trying to solve a problem that is old, which is road logistics problem. Okay, so how to move cargo from A to B, how to make sure that the supply chain runs seamlessly, and there is always a link between the shipper, which is these large companies like Coca-Cola, like Amazon, that want to move goods in bulk from A to B in order to make sure that then they can go to the last mile, which is, for instance, a restaurant, a big restaurant, or even a commercial center, or a supermarket. Giving the example of that industry of retail for people to understand, and the carrier, which is a truck company. Okay, and then here on these, we have to understand what is the reality of uh, carriers on the market. First, drivers. Large portion of the truck drivers today in Europe are 55, 60 plus or more. Okay, so it's a population that is aged. Second, the inefficiency. 30% of the kilometers that these trucks do are empty kilometers. It's a highly inefficient industry. Okay, they are running empty. Okay, and wasting a lot of fuel, and with that also having environmental footprint that is very high. And third, is very fragmented. Okay, 80% of the truck fleet in Europe sits with fleets that have 15 or less trucks. there are many drivers. They own their own truck, or they are working with their brothers, with their sisters, with their wives, with their sons, and they're a family company. They were one, two, three trucks and one, two, three drivers. That's it. Many, much more than you would anticipate. And there is also an industry that has a size of 400 billion euros, and where 5% of this volume, only 5%, is run by the top three players on that market, which is very rare. Typically, there's a lot of consolidation, not in this market. Okay, so there's a lot of opportunity for digitalization, opportunity for transparency, uh, and if you have opportunity for digitalization, you have opportunity for transparency, you have opportunity for efficiency, you have opportunity for machine learning. Okay, the type of problem, we try to build a marketplace that connects these shippers and carriers seamlessly, where not only you can find all the information in one place, but you can also deal this transaction seamlessly, a little bit similar to the Uber business model. Actually, Uber as a company, as a branch called Uber Freight, that does exactly this. In the US, you may know about them. So and so around that marketplace, we are trying to build a value proposition where there is a flywheel, so an automated flywheel pumped through data and AI technology developed in house, where everything around that marketplace experience is driven through personalization and automation. We're talking about everything. We're talking about search. We are talking about matching. We are talking about pricing. We are talking about recommendation. We are talking about eligibility. And then this brings problems of forecasting. This brings problems of optimization and routing. This brings problems of ranking and recommendation. So spanning, I would say, across most of the problem that I can think on inside supervised learning, reinforcement learning, even and operations research. So it's very vast uh, area, always around, I would say, more towards predictive analytics and not so much about, for instance, pattern recognition and reasoning. So text and image mining, which is something that is popular these days, but it's not so much about that. But it's more about, you know, control, matching, predictive analytics, and efficiency, which I think it's still, given the impact it can have in the world, because I bet that if you are in Europe today and you are on a room, most likely there will be an object that was transported in a truck that was dispatched by Sennder inside that room. So it's really has really an impact on the world you live and on the physical world you live. So that is it's really exciting,
Wow,
really thrilling. Yeah.
that's a very powerful statement to make, right? Like if you're in a room in Europe today, most likely you have an object that was transported by said.
Yes. Yeah. Yeah.
It's amazing. And I can also, by the way, given the, I also learned quite a bit about the industry overall and the state of the market that I could not imagine that top three players have less than 5% of the market. Typically, I would notice that most industries have top 3% cover. I don't like 50, 40, 60
Correct.
of the market,
Correct.
right? So it's very interesting to know this, Lewis. Now, Lewis, you also highlighted a lot of different types of machine learning problems, right? That you can imagine that it's getting solved here. Would love to understand that, given the maturity. By the way, imagine that most of these machine learning models are already serving production traffic, right?
Yeah. Today, just a few. We have just a few use cases of these are serving production traffic, but the others are still in stage of POC and ideation. So on the way,
Got it. Okay.
right? So yeah.
Got it. Understood. So, when you think about some of these models that are serving production traffic today, I would love to get a view of where are these models deployed today, okay? And also, from the previous question about like how have you structured the team in terms of, like, people who are building the model versus deploying the model? Like, what's the process of getting from development to deployment stage, basically?
Yeah, very well. So I can tell you, these models are deployed on Kubernetes cluster.
Yeah.
So to the date where they live in, and then depending on use case, they can be served either batch
Okay.
or point, depending the requirements. So the requirements in terms of SLA and what makes sense for that specific use case. Can go more detail on that point if you are interested. Then to your second question, so we build teams. So I know that this is a hot topic in the community. Who builds versus who deploys? Who does the notebook and the art, and versus who does the engineering? But um, I will say it also another strong statement. I don't believe in that. So I do not believe that so machine learning engineering is a discipline, in my perspective, of creating machine learning embedded services that work
Yeah.
at scale. So yeah, we need to train models. We need to validate them offline, and then we need to deploy them and run them at scale. Only then we'll add value. There is no value on notebooks. There
Right.
is no business value on notebooks. And there is no business value on the random API calls of some
Right.
library with a lot of data. So it must be end to end. So the teams are asked that. So the teams are organized around domains
Okay.
where the team has end-to-end responsibilities, and everybody in the team is expected to know how to train a model, how to build a new feature, how to deploy a model, and how to fix a bug on a pipeline.
That's
now
amazing.
now I know it's difficult, it's very difficult to find supermen and superwomen or superhumans that master all the disciplines necessary to cover this. So inside of the teams, there are different experts on different parts of the pipeline. No, but nobody has a different title. Everybody is an ML engineer, and everybody knows who is strong on Kubernetes clusters, who is strong on Terraform, or who to go to ask about
Got it.
loss functions on ranking. Okay, so but the team is end to end, and through collaboration, they should own the entirety of the code base and the entirety of the product lifecycle.
Got it. I see. Well, I think that's a good structure, because even if, so one, you all are aspiring for every individuals to get end to end, but given the practicality, like, you're also comfortable with the fact that you have some specialists in the team, which makes sense. But given that the responsibility is at the level of a team, there is a sense of shared responsibility, basically, that we as a team need to deliver this end to end, and it's not like, somebody else's problem, basically. So I guess
Yeah,
that solves for the issue overall. Yeah.
yeah, absolutely. And there is a lot of reward on collaboration.
Right.
And what I expect in the end of the day is to have individuals with high emotional, so EQ and high IQ that are solving problems. And
Right.
some of the problems they have more experience than in others. Okay, they're giving their background, but in others they don't have so much experience, but they gave the sense of ownership that this is my problem to solve. I
Right.
may not solve it with the same elegance that other colleagues. I may take 2 days or 3 days while others will take 1 hour, but still it's still mine to solve, because
Right.
that's how I pay my salary, that's how I return the value to the company, this level of ownership. So this is imprinted from the teams from the very beginning and from inception. Yes.
That makes a ton of sense. So, Lewis, maybe, like, touching a bit more on the Kubernetes aspect of it. You mentioned that everything is deployed on Kubernetes. Like, are you all using any cloud maintained Kubernetes, specifically?
Yeah. So we run everything on Amazon, okay, AWS, and then everything on ECR. Then in terms of um, MLOps stack, so the way we go through it. So we work in terms of experimental tracking. We work with weights and biases, okay, and also connect that with flights and with BentoML flight for pipeline training or orchestration. So let's say this way, and then BentoML for standardization of model serving. So here on a mix between commercial stack, like as you can see, and an open source stack, and then doing experiments with managed Jupyter notebooks and Ray for FIDE and also for model training. Whereas I'm not sure that it's already production, but it's to it production very soon.
Oh wow. Okay. So it's a very like you've handpicked. So the trend that I'm seeing in your stack that you've chosen for the most part, maybe beside weights and biases, is you've picked up open source packages. So like Flight, Bento, Ray, uh, in your stack, and you have and do you host it yourself? Do you manage it yourself?
We host proudly flight ourselves,
Yeah.
and we proudly as well host Bento ourselves, and I think that will host Ray ourselves as well.
Wow. Wow. Okay. So then you really have a lot of Kubernetes experts in the team who are able to manage some of this, I guess this distributed workloads on all of these different softwares basically. Yeah.
Yeah, definitely. If people very curious, okay, solve the next problem, but with a lot of ownership to run it. It comes at challenges at times. So uh, I'll not lie, but so far we have been overcoming the challenges. And then weights and bias is what we see is that there is return of investment on having such a complete orchestrator that really makes the life of the team working at scale easier. So there we invested a bit more, but this keep our choices open as much as possible for the time being. Okay.
Got it. Super helpful. So the other question that I wanted to ask here, and especially given the stack that you just described, right? So you have a team that kind of owns a problem end to end. Okay. uh, which means it's kind of almost by industry verticals or like the specific business problems that the team is trying to solve, right? Now this stack that we're talking about, like the BentoML and the Ray and the Flight, etc., is likely a common stack across all the teams basically, right, that are solving different problems. So
Correct.
if there's a separate owner for this, like bringing up the stack and maintaining the stack in the team.
So on one side, I would love to answer to that yes,
Yeah.
because that will mean that we'll have an MLOps platform team that would be holding these horizontal products to multiple teams to use it.
Yeah.
The thing is, at least for the stage where we are right now,
Yeah.
so I don't think that's the most efficient way. I think we could, if we would invest on that team, would be taking resources away from the domains where we still need to do it. That I think it's the main difference for an organization that will have, I don't know, 50, 100 people working on AI is that we need to do more with less, and that
Yeah.
means to have more ownership. So what we have is we have domain teams that also own horizontal components. I'll give you an example. So we have these two core teams, one for the recommender, another for pricing. Okay, ML recommendations and ML pricing. So ML recommendations owns the horizontal component of BentoML.
Okay.
Both ML pricing and recommendations use that on their services. ML pricing owns the horizontal component of Flight. Both pipelines of ML recommendations and ML pricing are on board on Flight. Okay, so in this way, we can keep a little bit the teams more into it, try to do a little bit more with less. Albeit, I do think with the growing of 3, 4 teams, it may make sense to reduce the cognitive load of the teams and having a separate team uh, that is only maintaining this type of component, but that requires a different scale where we are not at the moment. Yeah,
I see.
in my
Okay.
opinion. Yeah.
Okay. Got it. That's super helpful to know. And this team, like let's say that's building out some of the stack on top of this open source. like tech stack basically, are they also exposing some tooling for the other team to use basically, like kind of a layer on top of it, or it's kind of exposed as is? Let's say like a flight would be exposed as is, a ray would be exposed as is, a BentoML would be exposed as is basically.
Different answers there. Okay, depends on the technology because they so they were comparing the different technologies for different purpose. In some cases we do have a layer, in some cases is as is. So most of these technologies have a usage only on the machine learning arena. I think that the most generic one would be flight. With flight there were some, and there are some still interested parties in the company of having a look, because flight is a very versatile orchestrated, and obviously there are other use cases beyond ML, but still no production users beyond my SenAI org. So out the answer would be mixed. Some of them with layers, some of them as is, mostly for internal consumption, but perhaps in the future things can change as
Got
well.
it. Understood. And it seems like you made a deliberate choice to build a stack using this open source stack instead of, let's say, using something like a SageMaker. Or do you also use SageMaker internally?
Not yet. Not yet. So SageMaker, we looked, for instance, on the managed Jupyter notebooks that are
I see.
basically SageMaker as a solution. So the way we deal with this, so I do know, and many people comment with me that typically Stack is a top-down decision on their organizations. Okay, that where the director or CTO say, okay, this is the stack we'll use to do X, Y, Z, and that no, everybody follows. This is an approach. So I really believe on the DevOps approach. You build it, you run it, right?
Yeah.
Try to expand that as well to the discovery of stack. So okay, so we need new stack. Which are the requirements? Put down Moscow priorities, okay, and do the collective discovery. So we did that exercise. There is even a blog post about that we did at the beginning of the year. But I did this exercise for some challenges, and we reached the conclusion, okay, initially from separate discovery that SageMaker could be a solution, namely for orchestration and for um, also for model serving. But then when we tried to make it work together with some open source stacks, so we discovered like the needs of customization that we had our products versus how the freedom we wanted to have also to build in open source components. We discovered on a POC that this didn't work well together. So then we end up not no following Nash theory and not picking the first line of our discovery, but ending up picking second lines that go well together. Okay, which compatibility between the stack is also very important to use them together. And this has been a process driven by the team members that collectively reach to a decision, and then they run it. And sometimes they whine why we picked up this or that, and say, "Well, now you picked it, so now you
Correct.
run with it." Okay, so that's so I didn't have any merit on the pickup of these choices, I'm afraid. So
I see. Yeah. No, that makes a ton of sense. And by the way, I would like to call out that clearly you have been yourself and worked with like math and stats professionals, because you use following Nash theory as like colloquially to describe like a common problem that you're trying to solve, which is very unlike most people, right? So uh, anyways, so Lewis, here like you mentioned about some when you try to make SageMaker work with the rest of some of the open source stack, it did not work out very well, right? Any chance you remember one or two problems or examples of problems that you ran into that did not work with SageMaker and you had to switch to like the kind of line two of defense basically here?
yeah, so I remember that the basically to make we struggled to make it work with weights and biases. The technology of this, it was a long time ago, like 1 year and a half, 2 years ago. So I remember in general with other open source tools was tough. I don't not remember. No, exact the
Okay,
technicalities of it. Yeah, I can follow up on that with the people that were more close the
makes sense.
decision. Yeah, but I don't recall. Yeah.
Makes sense. No problem at all. And switching a bit, to learn a bit about are you all doing anything with generative AI currently, or uh,
Isn't everybody doing something in generative AI? Okay, so of course that the bulk of our data is not textual. Okay, we
yeah,
have to understand that. So, however, we do have a text, and we do have programs that would benefit of natural language processing, and with that, obviously, looking to generative AI and the recent developments in the field with a lot of interest and enthusiasm, and doing some POCs here and there. Yeah, about that.
okay, got it. Makes sense. I think that's why I asked this question, because intuitively it sounds like most of the data would be structured, time series type of data sets, and you may not have enough concrete use case for generative AI basically. So that's what makes sense. Uh,
At least on the sense of NLP. But if you think about generative AI a little bit,
Broadly,
wider, or what is broadly about what is generative AI and what is, like, for instance, the development that came ChatGPT on reinforcement learning from human feedback. You
right?
see the right, very interesting for me would be to explore. So the routing problems, which has been traditional a field for operations research for
Yeah,
many decades, okay, where reinforcement learning has been growing, and I believe that this generative AI wave will bring possibilities to push that state of art even further, to build the routing more dynamic, to take in consideration not only the positioning of the vehicles, but prices, margins, supply and demand, and things that are a bit more, flexible, and move where rules move with time, and you need to adapt your decision making. So I do see there possibilities of um, different type of solution space being explored on that problem on the mid run, and we are building a team
okay.
towards that at the moment, and so let's wait to see.
Makes sense. And for your early experiments with some of these generative AI experiments, have you chosen a provider that you're currently using? Like the how are you running your early experiments basically?
So for us, so far has been testing some APIs, so out there, and using what we already have on the stack. So we didn't still did experiment at the scale that you justify go beyond what is free or open source. Okay, because we're also not doing anything in in production. I'm sure in the day that we want to do something commercially, there will be no shortage of providers that will provide the solution if we need one. One thing that I also have to denote is that weights and biases is also a solution that is, very resilient also on the Gen AI surface to manage these experiments. But it is something that's already native from our stack.
I see. Okay, got it. So, but weights and biases would solve the problem of, as you said, managing the experiments, right? They would not provide you the models, or are they providing you the models as well, basically, like hosted model endpoints or something?
Yeah, that no, but we still didn't. I mean, did a volume of experiments that would require somebody to be hosting a model specifically for us, or even fine tuning a model beyond, a local machine, okay, and running one of these smaller models that exists so out there, which I have to say that they are smaller, but they have more than enough powerful for a lot of applications. For these, you see that we are not being very serious on the bet that we are making this yet, but it's something that we are considering, and that evidently, like, depending on results of the ongoing POCs, we may.
That makes sense. That makes sense. Super helpful. Thank you so much for walking me through this entire stack and the problems and problems that you all have solved overall, and how you have built a very unique and cutting edge stack overall. I would love to talk a little bit more about anything. So you shared a little bit about generative AI and it's the type of problems that you could be solving with this, right? Like moving forward. And you mentioned that you're building a team around it as well to solve the specific problem of generative AI, using the path planning and stuff, basically.
Correct, correct. So we are not building a team, to be clear, about generative AI, but we are building a planning team. Okay, so then the solution space, I leave it to the team members to decide what is the best knife for the cheese. Probably, I would say the first launch will not be a Gen AI, or neither the second launch, neither the third launch. But who am I to say? That's just my because simple is beautiful, simple is easier to maintain, is easier to debug, and when you are doing product market fit, this is more important than being very accurate. Okay, and that is true for a machine learning product life cycle, or for any product life cycle. So I would not expect the team to go straight to there, but I would expect the team to look into that as time moves forward and matures. So, and regarding the team, we made already one hire, and we are looking to make at least two more specific, only to work on these problems, yeah,
That
till the
makes
end of
sense.
the year.
Super nice. One last question: are there any books, podcasts, blogs that you follow to keep yourself abreast with all the latest and greatest developments in AI? Would love to hear any recommendations there.
Yeah, a lot of things from O'Reilly, obviously. Very so recent things from. I mean, there is a book that I like particularly much, which is from Cathy Shen. Okay, so other authors, but it's about reliable machine learning and applying SRE principles to ML in production. I think it's very interesting. So how they draw parallelisms from from DevOps to ML, and that how that makes sense to build solid and resilient and reliable machine learning applications that are like other Bibles. I like very much the generative deep learning from David Foster, as well a book from O'Reilly, quite interesting for somebody that is starting on generative deep learning, but also with contents that for somebody that is more advanced to to understand and all these possible applications. And there is a lady as well that has very interesting books on machine learning. Yeah, her name is Ship Uyen. So, and the ML system design book. So that she authored, I believe, also O'Reilly. Very interesting on how to build all the stack and how to approach a machine learning problem, Greenleaf machine learning project. Also something that I would recommend reading. Yeah.
Makes sense. Absolutely. Thank you so much for sharing that, Lewis. Really, really appreciate you taking the time and coming here and sharing your knowledge with us. I'm sure this this decision on the MLOps stack would be useful to a lot of our listeners of the podcast. So, thank you so much.
Absolutely. Was a pleasure. Thank you for the invitation.